Okay, we're going to be talking about writing equations. This is one of the most important things that we're going to talk about in all of algebra, and that is taking a word problem and distilling it down into a symbolic representation to put it into an equation. And by the way, an equation is simply two things separated by an equal sign that have the same value on both sides. So you could say, well, 5 equals 5, right? So this has a value of 5, and this has a value of 5, and these two things have the same value. So that's what an equation represents. And throughout, kindergarten and all the way up, you did things with equations. 2 plus 3, what is it? Equal 2, right? So this has a value of 5, and this, we would say, is a value of 5. Now you could say 5.0, right? So there's different representations of things that have the same value. And when we go into algebra, we're going to start using placeholders and symbols for things. So if we have something like this, a number that we don't really know, it could be, it could have a value of something, or it could be variable. It could be represented by a bunch of different numbers. Like I could put a bunch of different numbers in for this value, and so we just call it kind of like a placeholder. And maybe you remember this. You saw things like blank plus 5 equals 6. That's what this placeholder letter or variable is called, is just a placeholder. So you can see x plus 5 is equal to 6. And what is that value that makes that statement true is generally what we want to find out. So this, if we said x is equal to 5, that means the value of this variable x is equal to 5. Okay. So now we want to take words, put them into a pattern that's like this, so it can be a more simple representation. And equations have a lot of power in that there's ways to manipulate them in algebra that help us find the value of that unknown quantity. Okay, so let's jump into it. When the steps that I like to use, and other people have written other steps, but I like to just think of it this: I'm going to read the question, draw a picture, or at least visualize it in my head, put myself in the situation. This is kind of a key step for me, and it helps a lot of students to really take a minute to just think about what is the situation like, and that's kind of a draw or visualize step. Okay, and then we're going to write the equation, and then generally we'll solve it and check it, but we're not going to worry about these two for now. We will get to them later. Alright, so first I'm going to read this question. It says, write a rule for the pattern in terms of n for the total number of sticks t. So this it looks like here this is step 0, or n equals 0. This is step 1 and step 2. So I want to find a general equation for any number of steps, right? And so the first one had the total number of sticks t was 4, and this total number of sticks t, and this is what we did in our opening problem, was 10, and t, the total number of sticks, was 10 plus 6 more, right? 16. So what happens is we're generally adding 6 each time, right? So when you repeatedly add the same thing, that is multiplication. So for the number of steps, it's going to be 1 less than, well, if I start with 0, so step 1 I'm going to add 6, step 2 I'm going to add 6. So the number of steps, I'm going to, however many n is, that's how many times I'm going to multiply by 6, right? Because this is n times 1, or 6 times 1, 6 times 2. I added 12 to 4, right? So if I repeatedly add the same thing, this is called multiplication. So 6 times the number of steps will be that part, but I have to fix it because I don't start with 0, right? I don't start with 0 sticks. I start with 4 sticks. So I'm going to add on 4. And just to check my answer, let's see if this works for the different number of steps. So if I plug in 1 for n, 6 times 1 is 6, plus 4 is 10, and then if I plug in 2 for n, that is 6 times 2 is 12 plus 4 is 16, so it checks out. And this is the total number of sticks, t. So this is what we call a linear equation, and we're going to get deeper into that. But just to find out what the general rule is for these types of equations is we find out the rate that it changes each time. That's going to be our multiplier. And our initial condition, what we start with, is what's added on. Okay. Now let's take a look at another one. Given a bill of $B, write an equation to determine the amount paid with a 15% tip. So let's draw or visualize. So we're going to be given some bill for some amount of money, right? And then we want to determine the amount paid if I'm going to pay an additional 15% tip. So it's going to be whatever this value is, so we'll just call it, I don't know, X. And then I'm going to add on 15%, right? So 15% of X, right? This value. And that would be my total, right? So my total will be, I'm ready to write my equation. It's going to be this value, we'll call it X, plus 15% as a decimal will be 0.15 times X, okay? So that's my equation, and you might see it written a different way. If I say, well, this is just 1x, and I'm adding on 0.15, so it's 1.15x. That might be another way to write it. Okay, so different ways to write these things. All right, up next, a checking account is set up with an initial balance of $4,800, and $400 is removed from the account each month for rent, assuming no other transactions. Write an equation whose solution is the number of months M it takes for the balance to reach $2,000. So we're starting with some money of $4,800 is in the account, so this is kind of like our bank account here. And then each month, so this is kind of like time occurring, right? Each month it's going to reduce by 400. So another 400 is 800, right, from the original. Okay, so it's going to occur like that, and we're going to repeatedly subtract 400, right? So what happens when we repeatedly subtract? Well, it's the same as multiplying by the negative number, right? So we're going to repeatedly subtract 400. So that's, we start with, our initial amount is 4,800. So we're going to start with plus 4,800. And then we're going to subtract 400 each month, right? So 400, negative 400 times the number of months plus our initial value of 4,800 would be the amount that we end up with, our total. Or actually, they gave us a value here, didn't they? Say it takes to reach 2,000. So at some point, the total is going to be 2,000, where it's going to be 4,800 minus 400 times the number of months. Okay, so that's my equation. Okay, up next. A library fines 50 cents for each day late beyond 7 days. Write an equation for the fine F in terms of the days checked out, D. So you check out a book, and you keep it for 1 day, then no fine, right? 2 days, no fine. 3 days. So actually, you have no fine for the first 7 days, and then all of a sudden on day 8, you get a fine of 50 cents, right? So the total fine is going to be, it's going to be kind of offset. Like we want to find out when does the days exceed 7, right? So these kind of first 7 days don't matter. So if it's checked out for D days, it's going to be D minus 7, right? Because now if I said 7 minus 7, then it'd be 0. It'd still be 0. So this is the number of days checked out where they start charging the 50 cents. And then after that, Okay, so after we hit day 7, then it's going to repeatedly add 50 cents each day. So plus 50 cents, plus 50 cents, plus 50 cents. So that's multiplication, right? Repeatedly adding 0.5. So it's going to be 0.5 times, or 0.50, whatever, times the number of days past 7. So D minus 7. Okay. And this, we have to, if it's we have to assume it's greater than 0. Because if we had, 5 minus 7, then it'd be negative 2 days. And you don't actually make money, right? They don't give you money for turning it in early. So we have to kind of assume a range. So D is greater than or equal to 7, right? It's only true for D values greater than or equal to 7. Okay, so that is writing equations, and we have a few examples for you to do next.